This is the introduction to the chi-square test of independence. I'm just going to go through some vocabulary and some general information. This first slide, I've created a bunch of other websites, YouTube videos and such. If you want to check them out, you're welcome to do so. I also have some of these on my website too. So as we move through the next few days of chi-squared, if you want to, download the notes for this, I'd probably recommend you do so you can save yourself a lot of time in writing. All right, here's what chi-squared is. It proves if two variables have a connection or not. Are they independent or dependent on each other? And what we're going to do is pretend to go out and take a survey. And we collect that data. That data is called the observed values. And what you get out later on is this chi-square test. And I'm just kind of being vague for right now. We're going to go through one together later on. And we're going to figure out, is the data that we collected with the variables, is it make a difference that they are independent or dependent on each other? So I'd say you probably don't need to write any of this down at this point. Here is some vocabulary that you're going to need, and I would say these I probably would write down. So number one, this might look familiar to you if you've had a science class. HO is the null hypothesis, it's called. This is the hypothesis test. If it is successful, the factors are considered independent of each other. If not, we accept the alternative hypothesis, H1, which we call the alternative hypothesis. We accept if HO is rejected, so the null hypothesis is rejected, this implies there's some kind of connection between the two variables, the two factors. So when we start off our chi-square test, you're going to hear these words a lot. The null hypothesis, the alternative hypothesis. All right, moving down. And if I'm going too fast, again, make sure you pause. The next thing is called chi-squared. It's a test to use to see if there's a difference between the observed and what you are supposed to get, your expected values, in a normal distribution. And so what we're going to do is we're going to do a chi-squared test. It's going to involve 7 steps. It's pretty long. All right. There is a formula. You can write it a couple different ways. Depends on the American way or the IB way. This would be the more American way. Chi-squared value is taking the sum of your observed minus your expected squared divided by your expected. There's also this notation of the formula, and this is the IB notation. They just use FO and FE. So this is IB. This would be more of the American way. Let's just go ahead and write down that formula for chi-squared, and that's calculating it. Then we have 2 more definitions, the observed values. So let's pretend you go out and you collect data. Those observed values are your sample. Then what's expected, we're going to calculate what should happen. And make sure definitely that you write down this equation right here. It's taking the row total times the column total and divided by the sample space. The next definition is called significance level. This is a level which we decide the observed frequencies are unlikely to have happened by chance. Usually we try to do this at a 5% chance, so if you're going to write an IB project paper, let's look for 5%. Sometimes your homework will say 1% or 10%, but for an IB paper, just use 5%. Critical value, number 7. This is the value of the chi-square distribution. So we're going to give you a chart that you'll need to go out and find this critical value. And above which you reject the observed. Don't worry too much if you don't understand everything quite yet. That's all right. We'll go through a problem set later. Degree of freedom. You'll hear that. Is the dependent on the number of groups being tested and determines the shape of the distribution. If the V, which is the degree of freedom, so that's what IB textbooks use, and DF is more American way, if it is normal or not. So the formula we use for the degree of freedom is the number of rows in the sample minus 1 times the number of columns minus 1.